Today we're looking at operations with rational and irrational numbers. Our objective is we're going to multiply, add, and subtract radical expressions, determine whether the sum or product of two numbers is rational or irrational. Our first part is we're going to multiply radicals. Radical expressions can be multiplied if they have the same root or index. Multiplying the numbers outside the radicals together, then we're going to multiply the numbers inside the radical or the radicands together. Then we're going to simplify our answer. So on number 1, if I have the square root of 6 times the square root of 27, I could put that underneath the square root. Now what I'm wanting to do is I want to break these down as much as possible. 6 breaks down to 2 times 3, and both of those are prime, so we stop. Now I know that 3 goes into 27. 3 times 9 is 27, and then 9 breaks down to 3 times 3. I'm going to find all of the pairs. I have 2 sets of 3s. 3 times 3 is 9, so the 9 comes outside the square root, and then we have a leftover 2 inside the square root. Now you can put this in your calculator, and most calculators will do this if you have the right one, but this is where the calculator is getting those numbers from. Number 2, 5 times 3 is 15. And then we have, underneath the square root, we have 10 times 24. Now I could times those together to give 240, but I'm just going to break it down again. We want to get these numbers as small as possible. So 10 breaks down to 2 and 5. 24, we could do 6 and 4, 2 and 12, 8 and 3. Let's do 8 and 3. We've got 3, 2, and 5 are prime. 8 is 2 times 4, which breaks down to 2 times 2. So any pairs we have, we're going to circle those. We have a 3 and a 5 that are left over. So we're going to multiply our 2's and our 2's here to give us 4. And then we're going to multiply that 4 by the 15. 15, 30, 45, 60 is going to go on the outside of that root. And then we're going to times all the leftovers together. 8, 4, 10, and 24 have all been broken down, so we're not using those numbers. We're just going to use our 5 and our 3. 5 times 3 is 15, which is going to be left underneath the root. On number 3, we're going to multiply the outside numbers. 4 times 3 is 12. And then on the inside, 13 times 13, both of those are prime, but they are actually exactly the same. So we're going to take that 13, pull it out front, and we're going to multiply 12 times 13. Now I actually don't know what 12 times 13 is, but I know that 12 times 12 is 144. And if I add another 12 to that, that will give me 156. And that will be my answer there. Next, we're going to be adding and subtracting radicals. Radical expressions with the same index and radicand are like radicands. Radical expressions can be added or subtracted only if they are like radicands. So, for example, number 4, we have the square root of 3 and the square root of 3. Both of them have the same index, which is 2, it's the square root, and they both have the same radicand, which is the square root of 3. So we have 4 square roots of 3 plus 5 more square roots of 3. That's going to give us 9 square roots of 3. 5 also has like radicands. We have 3 square roots of 5 minus 7 square roots of 5. So 3 minus 7 is negative 4 square roots of 5. Now number 6, we have a square root of 8 and a square root of 2. These are not like radicands, so we cannot add them together. However, we can simplify the square root, and then we can add them together. So 8 is not a prime number. It breaks down to 4 times 2, and 4 breaks down to 2 times 2. The 2's can come out with a 3. 2 times 3 is 6 square root of 2 plus 3 square root of 2. And now they are like radicands, so if I have 6 square roots of 2 plus 3 more square roots of 2, I have 9 square roots of 2. Number 7, we have 4 square roots of 2 plus 5 square roots of 3. These are not like radicands, and so we cannot add those together. So we can't combine them as like radicands. So this is as simplified as it goes. We cannot add any more together. They will not combine at all. For numbers 8 through 13, we're going to look at each expression and determine whether the sum is rational or an irrational number. Let's talk about what each of these means. Rationals means it can be written as a fraction. And anything that it could also be of the form as a decimal that repeats or ends. Any decimal that repeats or ends can be written as a fraction. So when we're looking at rational numbers, we're mostly thinking of fractions. Irrational numbers are numbers that, when written as a decimal, they don't repeat or end. So let's go ahead and look at 1/2 plus 2/3. If I were to take this 1/2 plus 2/3, I could get a common denominator of 6. So I'm going to times the first number by 3/3 and the second one by 2/2. This will be 3/6 plus 4/6 gives us 7/6. So if I have a rational plus a rational number, that's going to give me a rational end solution. Number 9, I have a rational number. It can be written as a fraction plus a rational number. When I combine these, I need to get a common denominator. Both 4 and 6 go into 12. So I'm going to times the top and the bottom by 3 on the first one, and the top and the bottom by 2 on the second fraction. This gives us -9/12 plus 14/12. 14 minus 9 is going to give me 5/12. Keep the denominator same at the top. So a rational plus a rational equals a rational number again. Now the square root of 7, it cannot be written as a fraction. If you were to write it as a decimal, it will not repeat, it will not end. So a rational plus a fraction, an irrational number plus a rational number, if you put this in your calculator, it won't give you a nice fraction. It will give you just a decimal, a long decimal thing. So this is going to be an irrational number plus a rational number is always going to give us, well, it will give us a irrational number. If I take a -1/2 plus a square root of 3, this will give me a rational number plus an irrational number. The solution is also going to be an irrational number. 12, we're going to take, we have two rational numbers, and a rational number plus a rational number is actually always going to be a rational number. But an irrational number plus a rational number, a lot of the time it's irrational, but sometimes, like if you had the square root of 5 minus the square root of 5, or a negative square root of 5 plus square root of 5, that would equal 0, which is a rational number. So, will the sum of two rational numbers always be rational? Yes. Every time you add two rational numbers together, you're going to get a rational number. If the sum a plus b is an irrational number and a is a rational number, what do you have to conclude about b? Well, a rational plus a rational is a rational. So since it equals an irrational number, b has to be irrational. Can the sum of two irrational numbers be rational? If so, we're going to give an example. So I guess I kind of did this too early. This should be down here. If I had a positive square root of 5 minus a square root of 5, or negative square root of 5 plus square root of 5, that would equal 0, which is rational. So that would be an example. Yes, it can be rational, and we have an example here. For 17 to 22, we're going to determine whether the product just means we're multiplying, is rational or irrational. When we multiply rational numbers or fractions, we multiply across the top and we multiply across the bottom. So this will be 6 over 15. This reduces because 3 will go into 6 2 times, and 3 will go into 15 5 times. So that would be 2/5. So a rational times a rational equals a rational number. Now on 18, we have an irrational number times a rational number. This is going to be 5 square root of 2 over 6, which is an irrational number. 19, if we make this over 1, negative 5 times square root of 11 is negative 5 square root of 11 over 9. This is a rational number times an irrational number, gives us an irrational number. 20, we have a rational number times a rational number. This is negative 5/12, which is a rational number. 21, we have a rational number times a rational number. This equals 77 over 77, which equals 1, which is rational. 22, we have an irrational number times a rational number. That would equal negative 4 square root of 13 over 3. That's an irrational number. Will the product of two rational numbers always be rational? Yes. You can't just suddenly get a square root if you have rational numbers. So it will always be rational. Will the product of a non-zero rational number and an irrational number always be irrational? So if I have a square root of 3, there's not any number that I can multiply that square root of 3 by that's rational that will give me a rational number. So it will always be irrational. Can the product of two irrational numbers be rational? So yes, it can be. And let me show you an example. So if I have the square root of 2, which is irrational, times the square root of 2, which is irrational, that would equal the square root of 4, which is 2, which is rational. So you can have two irrational numbers that end up with a rational number at the end. So we're going to categorize each expression as rational or irrational. Here we have an irrational number plus an irrational number, and altogether that would equal an irrational number. Square root of 5 is irrational. Square root of 4 is equal to 2, which is a rational number. And if I add those together, I'm going to get an irrational number. Square root of 4 is 2. This is a rational number. Square root of 9 is 3. This is a rational number. And so I have to get a rational number out of that. 5 times the square root of 3 is an irrational number. 5 times the square root of 16 is 4, which equals 20. This is a rational number. So we had a rational times an irrational number equals a rational. Square root of 2 is an irrational number. Square root of 8 is an irrational number. But when I multiply 2 and 8, I get square root of 16, which is equal to 4, which is a rational number. So we can multiply two irrational numbers and get a rational number out. Now on 32 we have 4.1876 ... it's not indicating that anything is repeating. So a repeating line would be like on 33 where there's a line above it. So I'm assuming this is going to be an irrational number where 0.333, if it repeats or ends it will be a rational number. This is equal to 1/3. If I divide that out, 3 into 1, it always gives us 0.333, and it just keeps going forever. Now on 34, we have 0.852. This is the tenths, hundredths, and thousandths place. So this is 852 out of 1,000. That will simplify, but you can write it as a fraction. So this is a rational number.